Now we're going to look at the DC setup for welding of steel and stainless steel. So the first thing we do is set the machine, make sure here we're in DC mode. We're going to be using the TIG welding process, so we can have either 2T or 4T. In this case we'll just select 2T, and we want to use high frequency arc starting, so we're turning the HF button on so that light's lit up. Okay. Straight away we have our main control here. Button is showing and our amperage is showing 100 amps. If we push that, we can change our output weld current to to whatever we like. But let's keep it at 100 amps for now. Depress the button. Now, if I go back through this sequence, right through, if I start here, my pre-gas flow. Now I only want very small amount of time, and this will time out if I don't make the adjustment quickly. But I can make that adjustment and turn up my pre-gas flow, anything up to 4 or 5 seconds or longer, but I don't need it. It's only when I've got a very long torch. So keep that very low at 0.1. We then go to an upslope time. So this is between our starting mode and my 100 amps, how quickly we get there. And this point, I'm in seconds, it's just 0.1 or 0.2 of a second. So pretty much I'll go straight to my weld current. So as I said, we adjust our weld current, but we're going to leave it at 100 amps. We then go to downslope mode, again in seconds. So at this point, we've got it set at 2 seconds. Again, I can turn that to 0 if I want it to be straight on off, or I adjust it to a couple of seconds, which means the weld will continue once I let go of the button, but will drop quickly in current and drop down to our base current from 100 amps within 2 seconds. Last one on there is the post-gas flow. As I've said before, we can adjust this down. You really want a minimum of 5 seconds, but it's really dependent on your output current and the size of the tungsten you're using. The higher the output, the larger the tungsten, also the longer the post-gas flow. So if in doubt, set it at 10 seconds and you won't have a problem. It is important because it shields the tungsten electrode particularly, and also the end of the weld pool, so you don't get gas pores or craters at the end of the weld. If we move to then, if we wanted to use pulse, we would then turn pulse on here. Then that'll introduce some more adjustable secondary parameters here. You'll see I now have a pulse percentage here. I also have a hertz frequency, which I can adjust anything up to 200 pulses per second. If I'm trying to simulate, and get a really good consistent profile with my TIG filler rod adding, normally that's about somewhere between 2.5 and 3 hertz per second that we're looking for there. Okay, so I'll set that on 2.5. The other adjustment then is going to be my base current. You see the bottom of the line here is my base current, so that's in amperage that I'm adjusting. So, if I adjusted that to 20 amps, what would then be happening is I'd be going from 100 amps, my primary current, down to 20 amps at that predefined pulse frequency of 2.5 pulses per second. So that's the adjustable difference between 100 and 20 amps, 2.5 times a second. We turn pulse off, again, those adjustments now go away because they're not relevant when we don't have the pulse mode turned on.